Hi everyone, this is the last lesson of Unit 6 and it's about similarity transformations, which is your dilations. And you're probably wondering, well, didn't we just do dilations already? Well, today we're going to learn a little bit more about dilations and how you can do a dilation with a center that's not at the origin. So we're going to learn how to do that in this lesson and also go over some basics of dilations. So you've got this figure here, and you've got A, B, C, D, and A prime, B prime, C prime, D prime. And over here is the center of your dilation. So notice that the center of dilation, normally, if it's at the origin, you would just multiply each coordinate by the scale factor, but that's not going to be true if the center is not the origin. So if the center is another point here, you're just going to make each point, like say if your scale factor is 1/2, you're going to make, if A is, let's see, this is -11 and that's 7. So if A is 18 units away from the center of dilation, then you would draw a line that goes through A and through the center of dilation, and then point A prime should be only 9 units away from the center of dilation if A is 18 units away. So it's going to be half the distance away from the center of dilation. So then each point will then lie on these two lines. So you could draw a line that goes through the center of dilation and through both of the points. So one other thing that I could point out to you here is if I drew a line through the center of dilation and through point B, it also goes through point B prime. Okay, so the slope will be consistent as well. All right, and here you can draw a line through the center of dilation, point D and D prime. So that's what we're going to talk about in this lesson. Real quick review. Dilations are either reduction, if it gets smaller, or enlargement, if it gets bigger. And if you're like Mrs. Billig, I already know this, I don't need to write all this down, then you don't have to. But if this is a good review for you and you want to write it down, then these are your notes and they're for you. So it is a reduction if the scale factor is between 0 and 1. So this is what you would put. And then it is an enlargement if the scale factor is greater than 1. So note, a scale factor equal to 1 will mean the image and preimage are congruent. K is equal to 1. In dilations, the image and preimage of a figure are similar. Unit 6 is all about similar triangles. This means the same angle measures, hence the idea of being the same slope from the center of dilation. You preserve angle measures and then proportional sides. So then each point is half the distance away from the center of dilation, or whatever your scale factor is. So the center of dilation is, this is important, this is a new part here. The center of dilation is collinear to or with the point of the preimage and image. This is a good way to check. That's exactly what I was talking about above with drawing a line through the center of dilation and through your image and preimage points. They should be collinear. You should be able to draw a line through all 3 of those points for each vertex. So that happens when you have even your center of dilation at the origin. It's just we haven't really talked about that too much. So to describe to describe a dilation, the 2 things you would need to state are the center of dilation, so if it's at the origin or a point, and then also the scale factor of the reduction or enlargement. So for this one, describe the dilation shown using a center point and a scale factor. So here's how you figure out where the center of dilation is. So this is the center of dilation, the origin, or maybe it's somewhere over here, maybe it's somewhere over here. How do I figure that out? So you take a line, take your protractor, and you draw a line through A and A prime. Okay, so A prime, and then I'm going to extend that line a little bit this way. And see how it goes through the origin? So just to double check, I'm going to do it for all three of them. So go through C prime, through C, goes through the origin, B prime, B. If I wanted to be really sure, I would find all of the slopes and make sure that they all end up coming back here at the origin. All right, and then to figure out if it is the origin, then we can figure out the points. So this point here, C prime, is, oh gosh, 9, 18. And then C is 3, 6. So it looks like you've got a center of dilation at the origin with a scale factor of 3. So center is at the origin with an enlargement with a scale factor equal to 3. Let's look, there's an example down here. All right, a line segment. Describe the dilation shown using a center point and a scale factor. So let's do the same thing. Let's draw a line through our 2 points. And where will they meet? Well, you've got that one. I drew it a little off. So you've got that one. It doesn't want to go straight for me. Oh, well, you get the idea. And then this one here. So then your center of dilation, it's not the origin. It kind of looks like it could be the origin, or maybe over here, but it's actually over here. So it's the point for -3. And then how much closer does each point get to here? Well, this is B is 4 units away and B prime is 2 units away. C is 6 units away and C prime is only 3 units away. So your scale factor is 1/2. This line segment gets half as close, or twice as close to the center, which would mean reduction of 1/2. So center is at point for -3, and then reduction with a scale factor equal to 1/2. Or you could say reduction of 1/2 with center of the point for -3. All right. Performing a dilation with the center point at the origin. So it says to draw the dilation of triangle XYZ, use the origin as the center and scale factor of 2. Okay, this is kind of like what we've already really done. I don't really see a need to do this again. You can pause the video and try it if you want to, but I'm going to skip this one because we already did this. You just multiply everything by 2. And then it should be, just make a triangle that's twice as big. All right, more onto these notes. So because the center of dilation is the origin, you can find the image of each vertex by multiplying the coordinate by the scale factor, something you already knew. Once again, this part here is just review. Note, this doesn't work if the center is not the origin. So that's the new part. In a dilation, the pre-image point, image point, and center of dilation should be collinear, what we just said. And then the slope of each segment is maintained after the dilation. The segments will be closer, farther from the center of dilation, but the slope is still the same. So if you did this question above, you can check that all of the slopes of the image, the pre-image, and the image are all the same. And then the perimeters should also be twice as big, 2 times as big. And then remember that the area then would be the square of that, so 4 times as big. All right, let's do some examples, another example of when the dilation is not at the origin. So we're going to draw the rectangle here. So -4, 3, 2, 3, and 2, -1. So this is your point A. B is 2, 3. 2, negative 1, negative 4, negative 1. All right, and your center of dilation is negative 4, 3. So 1, 2, 3, 4. 1, 2, 3. And then your scale factor is 1.5. So each point is going to be 1.5. And this is enlargements. It's going to be 1.5 times further away. So let's figure out what point or how far away, sorry, this would be C and D, AB is. So this is 1, 2, 3, 4, 5, 6. So if AB is 6, then A prime B prime is going to be 1.5 times that, which is 9. So this B prime should be 9 units away from A prime, which is the same thing as A. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then AD is 1, 2, 3, 4. So 1.5 times that is going to be 6. So A prime D prime is going to be equal to 6. So that would be this point here. And then based on that, you can figure out where C prime will be because it's just a rectangle. And so that's how these kind of questions will work out. So it won't ever give you something that is too hard to solve. That would require like advanced algebra to figure out. And then it just says to draw the dilation. So we don't need to write down the coordinates or anything. That would be the dilation. So for the center not at the dilation, it's important to remember that you can't just multiply the coordinates this time. Or sorry, if the center is not at the origin. So we'll start with point A. All right, so this really just walks you through everything that we just did. And then the perimeter of the pre-image, well, it was 6 plus 6 plus 4 plus 4, which would be 20. So then the perimeter of your image should be 30. Is it 30? Let's see. 9 plus 9 is 18, plus 12 is 30. All right, and then I've got a couple other examples for you. So in the coordinate plane, line P has a slope of 8 and y-intercept of 0, 5. So let's kind of picture that here. So it has a slope of 8 and y-intercept of 5. So 1, 2, 3, 4, 5. And then it's going up 8 over 1. So it's real steep here. And then down 8 over 1. So your line looks like that. Okay, so maybe that's not the best drawing, but you get the idea. Line R is the result of dilating line P by a scale factor of 3 with center at 0, 3. So the center is at 0, 3, right there. And you're dilating it with a scale factor of 3, which means it's going to get 3 times further away from the center of dilation. So use the y-intercept as your reference point. If the y-intercept of your pre-image is 2 units away from your center of dilation, and you're multiplying that by 3, then your new y-intercept should be 3 times further away, so 6 times, or 6 units away. So go up 6 units from 3. 1, 2, 3, 4, 5, 6, and where do you land? Well, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. So then your options here, the slope will not change. Slope should be the same. So then line R has a slope 8 and y-intercept of 0, 9. That one. And that is actually a question from an air test. So here's another example. Line P is dilated from center A by a scale factor of 2 to form the triangle Q. The vertices for triangle P are those ones. Okay, so let's go ahead and draw that triangle. It says graph point A, the center of dilation. All right, so it wants us to figure out what the center of dilation is based off of your image and your pre-image and image points. So let's draw it. So 2, 1, 2, 4, and 2, 1. All right, so we've got our right triangle. That should be easy to figure out. And then let's do this one. So -1, -3, 7, 3, and then 7, -3. All right, and remember, the way to figure out what the center of dilation is, if they didn't give it to you, is to just draw lines going through each point. So use a different color. So I'm going to draw a line going through this point and that point, through this point and that point, through this point and that point. Whoa. Something is off here. Why isn't this not working out? Let me check my points. -2, 1, 2, 4, 2, 1, then -1, -3, 7, 1, 2, 3, and then 7, 1, 2, 3. All right, what if I use the slope? So or maybe I just didn't do this correctly. So this would be up 1, 2, 3, 4 over 1, 2, 3, 4, 5. Up 1, 2, 3, 4 over 1, 2, 3, 4, 5. All right, so I guess I kind of overshot my. So that is one of the things. You might not just want to draw it like a vague picture, but you might want to go ahead and use a slope. Because when I did this, I wasn't exactly going through this point here. I was kind of missing it, so it might be helpful to use a slope. So 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. All right, there we go. So that's what that should look like. So that would be your center of dilation, point -3, 5. All right, so I think that is all for this lesson. So next you'll do the edge elastic for practice. And I hope you guys have a great day.